Good morning, everyone, and welcome to our webinar, XenApp Virtualization Success, How to Eliminate Storage and Networking Bottlenecks to Deliver Peak Performance. My name is Rick Ruskin, and I'm the Vice President of the Americas for EG Innovations. I personally work with a lot of companies looking to prevent and overcome performance issues around some of the most mission-critical IT projects, principally application virtualization, desktop virtualization, VDI, and more, Citrix XenApp virtualization. During today's webinar, you will hear from industry experts from EG Innovations and Atlantis Computing. Both company solutions are essential components in architecting and deploying a high-performing virtualized IT environment and are used extensively in some of the largest and most complex IT environments in the world. Today's webinar will address the issues that affect all Citrix XenApp and remote desktop services virtualization projects, including how to more quickly virtualize the Citrix XenApp environment without negatively impacting the user experience, hindering performance, or increasing costs. Today we will discuss how to architect an optimal virtualized XenApp implementation, how to automate XenApp deployment to speed up delivery of applications and data, and how to get peak performance from all layers of the virtualized IT environment. Our main speakers today are two very prominent technology experts in the areas of virtualization technology. Chetan Venkatesh, who is the Chief Technology Officer and a founder of Atlantis Computing, and Bala Vaidyanathan, who is the Chief Architect at EG Innovations. Now, before I review some of the challenges with virtualizing XenApp, let me go through a few housekeeping items and we'll get started here. As you listen to this webinar, you can submit questions at any time. Simply go to the GoToWebinar console on your screen and enter your question in the Q&A module. We will collect all your questions and answer them during the Q&A session at the end, and we're hoping to leave 5 to 10 minutes at the end to go through those. Also, we'll make the webinar slides as well as a recording of this webinar available to everybody who registered for the webinar. This might take a few days, and you'll receive an email with a link to the slides and the recording. Lastly, when you log off of the session at the end, you'll see a survey. So please just spend the extra minute or two online to give us some feedback on what you heard today and the quality of the presentation. So we can move to the next slide. So before we start, we know that a lot of people here are probably new to this topic, haven't heard from us before. I'll talk about the attendees in a second, pretty interesting. But I want to just take a moment to introduce you to EG Innovations, and then Chetan is going to do a little overview of Atlantis later on. You can go to the next slide, please. So hopefully what you hear today is going to be impressive and you'll want to learn more and see more. We want you to feel very comfortable that you're dealing with a very well-established technology. Again, not everyone may have heard of EG prior to receiving the invitation. So EG is a very well-established company. We've been in business for about 12 years. We are very much a worldwide company with a sales and service presence throughout the United States, Europe, and the APAC region. We have about 1,000 customers worldwide, and our customer base are really some of the largest, most complex Citrix, VDI, performance monitoring environments that you're going to run across. We have clients that we're managing thousands of servers for them, tens of thousands of virtual servers across multiple continents, and many of them have used our technology for many years now. So if you like what you hear today, you should be very comfortable. This is a very mature solution, has been around for a while. So, you know, our topic must have touched a nerve today. We had quite a turnout. There are roughly 1,300 companies that have registered for today's session. It's interesting, we often hear that Citrix is or was the last major application set to be virtualized in many companies. The fear of degrading performance and the cost that might be incurred to remediate those performance issues made many application owners resist virtualizing Citrix for years. Well, as you can see from this survey here, most companies are there now or plan to move to a virtualized XenApp environment very shortly. In fact, by the end of this year, we think most companies will have moved to 6.5 and most will have virtualized. But without proper planning, having the correct tool set in place to quickly identify why a user experience might be degraded, and using technology that will allow you to achieve high performance levels without budget-breaking costs are essential to make all of this work. So let me just spend a couple of minutes and frame the issues we're going to be speaking about here today and explain at a high level the complexities of virtualizing XenApp introduces. So first, performance management, even in a physical XenApp environment, is difficult. Probably a lot of people on the operations side with Citrix on this call today. How many times as a user that is used to logging in and seeing a Citrix window pop up every day, call to complain that Citrix is slow or Citrix is down, when in fact Citrix is totally healthy and the problem turns out to be related to network, SAN, or maybe even some database parameter that was misset. So thus the need for a product that can go beyond just looking at Citrix metrics and pinpoint the root cause of problems in the infrastructure or hosted applications is absolutely essential to run in these environments. Now, let's virtualize that environment. And not only do you add several more necessary components that impact the entire virtual ecosystem, and when you look at this, you're all familiar with the interdependencies between these different pieces. So you know that many of these, one small issue will have kind of a domino effect across the entire infrastructure. Something in the back end, a minor problem in a profile server could literally bring everyone down. And because there's so many interdependencies, it's very difficult to figure what those things are. But how do you know if the issue isn't being caused by some rogue application or rogue process or some user who decided to download some large YouTube video that's consuming all of the resources on the hypervisor, thus impacting all the other users and applications? So very often we're called in because all the native tools, vCenter looks good and Insight looks good, and all of the vendor-specific tools look good, but there's still a lot of problems. And what it turns out to be is another VM within the hypervisor is consuming all the resources. So unless you have a tool that can correlate between XenApp and its applications, can look at all of this supporting infrastructure I showed you here, and also has a hypervisor view, knows which VMs are coexisting with other VMs, it's almost impossible to figure out where these problems are originating from. So the problem is compounded where companies are committed to doing the virtualization, and the only way to fix this is to throw hardware at the problem, to spread the users out across more servers, build a bigger network infrastructure, and then to put in a very high capacity, high cost SAN infrastructure to guarantee total performance. So the result is Citrix managers often feel like this guy here. Users are complaining about hard to remediate performance issues, and financial guys are complaining about exceeded budgets. So what you'll be introduced to today are two very complementary solutions that address the two key inhibitors of a successful virtual Citrix infrastructure. Products that will help you ensure a positive user experience for your virtual application users, and products that will ensure you deliver your project on time and on budget. Now, let's take a closer look at as a solution to the performance management challenges we discussed a few minutes ago and delve into some of the best practices on how to ensure peak performance when you're virtualizing XenApp. I'd like to introduce now Bala Vaidyanathan, the CTO and Chief Architect at EG Innovations.
Thank you very much, Rick, and thanks everyone for taking the time out to join us for this webinar. Let's get right to it. Some of the best practices we've put together based on our experience in this industry for the last decade or so essentially boils down to these four major concepts. The first one is total performance visibility. As Rick showed earlier, today's XenApp environments are complex with a lot of interdependencies, and managing them from a siloed perspective is very challenging. Now, if you introduce virtualization in the mix, you've just added another layer of resource sharing onto the already existing Citrix resource sharing layer. So it becomes much more complicated to manage. The existing traditional approaches of performance management doesn't really cut it. What you really need to be doing is taking a total performance view of the entire environment. What we mean by that is consider performance of all the infrastructure elements and how they are working with each other, how they are interrelated, how is virtualization impacting this environment, and not just that, what are the services that are running on top of these infrastructure pieces and how they are delivering user experience. Being able to do all of this as a cohesive entity will give you the ability to correlate across all these different elements to, in a nutshell, say when there is a user experience problem, when there is a service impact, you will be able to correlate that to a back-end or infrastructure issue. And let's take an example of how that really plays out. Now, in this example, you're looking at the top-to-bottom approach where we are starting with the service view. Now, instead of looking at individual servers traditionally, which was the traditional approach, here the approach is looking at the service that is being delivered to the end user. In this case, you can see a couple of services here. One of these services is having a severe problem. You can notice by the color, which is not green. So essentially, Informat is a service that is having a serious problem. Drilling down from here exposes you to the next layer, which is user impact. Here you can see that there are a couple of transactions that are being impacted. So now from the service impact, you are looking at the user impact, how the user transactions are impacted, and what kind of impact it's going to have from a user experience standpoint. You can see application access and user logon are completely failing. So you know service is having a problem and users are being impacted because of that. From there, the drill down takes you into what we call as performance topology view. Essentially, what you see here is your common components of a typical XenApp service, your different pieces that are involved in delivering the service, and how they are dependent on each other end to end. So you can see the SQL servers, you can see the print servers, you can see the ZDCs, you can see the XenApp layer there. So you can see all these different entities, applications existing together, and you can also see the dependencies by the way of the arrow set, essentially showing you an end-to-end view of all the applications involved in delivering the service to the end user. So from here, it looks like XenApp is the application that is having the more serious issue. So drilling down from there takes you to the actual infrastructure layer. So if you notice, this is our top-down approach where we are looking at services, how the users are impacted, and how the applications are working together for this service, and eventually down to the infrastructure layer. You can notice that this XenApp is actually being run on an ESX virtualized host, which seems to be having the most critical problem. So in a nutshell, we've gone down from the user impact to essentially an infrastructure layer where the potential problem could be. Drilling down into the infrastructure layer gives you the nuts and bolts details. As you can see here, in this situation, the vCPU on the console of the ESX server is maxed out. Essentially, it is choking the ESX server out of CPU, and the XenApp servers and other servers running on the ESX host no longer have enough CPU to function appropriately. We can go one step further as a drill in to see why this is happening. And in this case, there were a few backup processors running, and that was causing the CPU spike and obviously the choking of the XenApp infrastructure and user impact. Now, essentially, when you're looking at this from a silo perspective, first time when you see a backup running, your immediate thought process is not to say, hey, how is this going to be impacting a service that is running on a VM that is servicing Citrix users. So this would be looked at as an isolated issue, whereas having the total performance visibility helps you correlate all of this information together and helps you look at this as a cohesive entity. So essentially, you are able to quickly drill down, find what the problem is, so your engineers are focused on fixing the problem rather than chasing the problem. As Rick mentioned earlier, most of the situations where we find Citrix administrators in is when there is a problem, they have to go defend themselves. They have to go prove it's not a Citrix problem before other organizations would even take a look. So most of the time spent in resolving issues that happen in XenApp environments, it's spent actually in isolating the problems. here we saw a quick approach where you can quickly isolate and get to the problem. Now to summarize that, it's great if you can actually find where the problem is as the problem happens in a complex environment, quickly drill down and find out what's going on. It's even better if there is a solution that can automatically do it for you, and you're seeing an example of that here. You can see a list of alarms that shows you all the different issues that are happening in that environment right now. And the software has the ability to, since it takes the total performance view of your service, it has the ability to correlate that information and tell you which are the effects as opposed to the cause. So here, the conclusion here is, if you notice the severity of the alerts on the left column, the CPU utilization, vCPU is identified as the most critical issue, and the rest of the issues have been identified as effects of that particular problem. So a software doing this automatically and sending out alert notifications or performing corrective actions based on this dramatically improves your user satisfaction, your IT team's productivity as they're not chasing problems all the time, and makes your entire environment more efficient in terms of delivering user experience and maxing out the infrastructure capabilities. No more finger pointing at the Citrix folks, but pinpointing where the actual problem is so you can get it resolved faster and move on to delivering the services. The second key factor is giving due importance to understanding user sessions, in-depth view into user sessions. Now, more often than not, a typical Citrix support call is a Citrix user calling you up and saying, hey, it's not working. Hey, my application is slow. Hey, I couldn't log in. Hey, it's very slow. The most important tool you need to troubleshoot this situation is to get visibility into that particular user session, understand what is going on in this user session, to be able to see if the user is doing something or something is going on within their session that is causing this particular condition to happen. In this example, we are drilling into in real time into a user session and a potential problem where the user is calling up and complaining. You can see the Excel EXE is consuming about 70% CPU. So it's not only critical to just look at ICA statistics, CPU memory statistics, but also need to understand what kind of the bandwidth is being consumed, what are the different processes that the user is running in real time, and what is really going on within the user session. So in real time, you can provide a tool to your help desk folks that they can use to quickly drill down into that user session, quickly find the user session, drill into the user session, and eliminate whatever is happening in the user session as a potential cause of the problem. More often than not, I would say 30 to 50% of potential issues that happen are contained within the session, within what the user is doing. So if you provide this first step, this efficient way to get to that particular user session, understand what is going on within the user session, your help desk folks would be able to resolve that problem at that first level very quickly. This obviously makes your help desk folks much more efficient, but more importantly, it takes care of your users' problems much quicker and reduces service downtime. Let's look at the third approach, which is proactive monitoring. We sometimes call it preemptive performance management. This is essentially critical in the sense you need to understand behavior of your environment over a period of time, and you need to be able to predict how behavior will be in future. And that prediction, automatically baselining your environment, gives you the ability to track and identify significant changes from normal behavior in real time, lot sooner before it really starts impacting your user session. And that's essentially critical in terms of avoiding user experience issues. It's great if you can find where the problem is when it's happening, but it's even better if you're able to avoid it. Let's take a look at an example. So this is an example where it says a Citrix server has gone down, TCP connection to 1494 has failed, and which is a normal event. But if you look more closely, you can see that about 30 minutes earlier, there was an event that was raised that said there was a memory usage issue. A particular user was consuming too much memory on that system, and all the processes and applications he was running was actually leaking memory, and it was creating a non-normal condition in the system. So you had a 30-minute warning before the system actually went down. So if somebody had actually taken a look at it, if you check the time between 11:43 and 12:13, if somebody had responded to this at 11:43, they would have potentially prevented this problem, the main user impact or outage that happened at 12:13. And essentially, that's where you really want to be. You want heuristics in place. You want automatic baselining in place to be able to say, hey, this is how my environment behaves normally. When there is a significant deviation from normal, that is when most of the problems start, most of the user impact starts. And I want to know it early enough so I can get in and resolve this issue before the users get really impacted. And that's how most fine-tuned environments are run today. And that's where all of us want to be. And the final point to talk about, this is actually a combination of a couple of points, which is monitoring of capacity. This is to understand how your infrastructure is being utilized and basically plan your utilization in such a way that you can maximize resource consumption, maximize environment utilization, and maximize your ROI. And configuration changes is the other part of it, which is we find that over 20 to 40% of the performance issues and outages happen because of configuration change. So anytime there is a configuration change, there is a very high likelihood of that potentially causing a performance issue. So your ability to track those changes and look at it in real time when you're trying to address a performance issue is critical for you to be able to successfully identify those and resolve them quicker. Let's take a look at a couple of examples here. So the first example here, we're talking about tracking configuration changes and how they're helping in isolating performance problems. In this scenario, we are looking at a situation where an Oracle database, if you can notice here, with the critical alert, has run out of table space. And that has caused what we call as a flow down effect, an overflow effect, where it has caused multiple other issues to happen as part of a ripple. So what has happened here is one particular table space issue has caused a lot of other issues in your environment, leading to user impact. But if you look deeper down into this issue, your ability to track configuration change, and if you can integrate that with your performance monitoring, you can see in this example, somebody had reduced the database size from 5 GB to 200 MB. And that configuration change caused the database to fill up. And that ergo caused a ripple effect and other performance problems. So being able to track the configuration change, not only track the configuration change, but associate it to a performance problem. So whenever there is a performance problem, the typical first question we ask is, what changed? And your ability to just click somewhere and be able to see what changed in that particular environment in question in the last 24 hours, in the last 48 hours, or during the problem duration, would gives you an enormous leg up in identifying and solving this problem much quicker when you're addressing performance challenges. Let's look at a couple of capacity-related observations. Now, in this example, you're looking at a report that gives you top users from a memory perspective. Who are the users who are consuming a lot of memory in your environment? You can do the same from analysis from a CPU perspective, disk perspective, having these kind of reports helps you understand your usage patterns. During which time of the day do you get maximum traffic? It is spread throughout the day, or do you have unbalanced servers where there are users who are only consuming CPU and memory is free? Can you mix and match them with memory-intensive users? These kind of reports help you analyze the efficiency of how your infrastructure is being used, and that typically gives you the visibility to improve that efficiency. Consistently, we see about 20 to 30% improvement in efficiency when you try to understand usage patterns, how users are consuming resources in my environment, and how can I pair them with other users, what can I move around to maximize infrastructure efficiency without compromising on user experience. Here is another example of a striking example of how this helps in real life. Here you're seeing a situation where from a CPU perspective you could have 22 more users in this environment, whereas from a memory perspective you can have only 3 more. Obviously there is a bottleneck here from a memory standpoint. Instead of just adding another system, if you just increase memory in this system, you would be able to maximize the resources available in the system much more efficiently rather than shelling out for new hardware. So directly improves ROI. An extension of this, isolating bottlenecks. It's critical. As Rick mentioned earlier, sometimes the solution to the problem is quickly adding more hardware. It works a minimal amount of time, works for minimal amount of times, because unless you understand where your real bottleneck is, unless you, for example, in this case, you're having an impact at the ESX layer because of an IO bottleneck. If you don't understand that there is an IO bottleneck, and if you just keep increasing the resources that are available, that is not really going to solve your problem. Understanding where your key bottlenecks are is critical in getting more out of your environment and at the same time keeping your user experience optimal. Here is another example of a storage bottleneck where essentially a storage device is quite simply cannot handle the load that is coming in. Now, if the user is complaining on the front end, and if you're focused on doing all the things by just increasing resources across all the different infrastructure layers, that's not really going to help this situation where there is a particular bottleneck in the storage environment. Our partners with Atlantis will talk about how they handle such situations and how they can help you here going forward. But the essential idea here is it's not enough if you simply throw more hardware at the problem. When you have an issue, a performance bottleneck, the real key is understanding where the performance bottleneck is. When you have the total visibility, it helps you understand where the real performance bottleneck is so you can address it accordingly, so you can efficiently use your environment better. Now with that, let's take a quick look at how EG brings all of this together. This is a peek into the functional architecture of EG, Performance Management Suite. Now here, you can see the 3 towers. We focus on infrastructure performance statistics, but not just look at infrastructure performance statistics. So we collect infrastructure performance from all the key areas that we need to collect across the entire environment. We also understand that this infrastructure is essentially used to deliver services. So we tie that infrastructure performance with the service performance, and then ultimately we know that the service is being consumed by the end user. So we also understand and track how the end user experiences. So our ability to bring all of this together as a cohesive entity gives us the ability to correlate across these different disparate pieces in infrastructure and services being delivered and help you assure performance in your environment to your users' benefit and to your IT staff benefit. Essentially, in a nutshell, total performance visibility. complete end-to-end service view, taking into account the nature of XenApp and resource sharing, adding virtualization into it and its own resource sharing, understanding services and user impact. Understanding all of this as a cohesive entity gives you the total performance visibility, and that gives you the ability to isolate problems quicker, reduce user impact, reduce IT impact, improve your ROI. Inside view of your user sessions, again, in-depth visibility into the user session and quickly being able to get to the user session, understand what is going on, helps you solve users' problem in one quick call, makes your 24/7 staff much more efficient, and takes care of user experience issues very quickly. Proactive, obviously it's good to be in a place where you can fix problems before they start impacting users by hence dramatically improving user productivity, and last but not least, understanding capacity and configuration and how they impact performance. With that, I'm going to wrap up and hand it back over to Rick.
Great. Thank you, Bala. That was really great. Appreciate you taking the time. Okay, our next presenter today is Chetan Venkatesh. Chetan is the Atlantis Computing Chief Technology Officer, as I mentioned, and a founder of the company. Chetan will talk about how to reduce networking and storage bottlenecks when you virtualize your XenApp environment. Chetan, it's all yours.
Thank you very much, Rick. A very, very good morning to everyone on the webinar this morning. It is my pleasure to be here talking to you about virtualizing XenApp and how to solve some of the storage challenges that come with virtualizing XenApp and moving from a physical to a virtual environment. So I'm going to focus on a few themes today when I talk to you. I'm going to focus on how do you simplify, accelerate, and reduce the risk that comes from this virtualization exercise as you take physical XenApp and make it into a virtual platform. Hopefully that was just the only point that Mr. Murphy will show up this morning. But let me talk a little bit about Atlantis Computing. We are a virtualized data center software company, and what that means is we provide technology that allows you to optimize many of the components that come with virtualization in the data center. We do three things specifically that are of a lot of value to you. Number one, we cut and in many cases eliminate most of the storage and the associated cost and complexity when you do VDI and virtualization. Second thing that we do is we actually eliminate many of the risks that come with attempting virtualization. You've had XenApp in your enterprise for many, many years, and you've been very successful with it. But when you try to virtualize it, you are introducing new moving pieces into the architecture, and there are many new technology and operational risks that come along with it. And our software and technology eliminates many of those. The third thing that we do that I think most people will get a lot of credit from their users for, and really there's not enough credit in the world that IT administrators get for the great jobs that they do, is we actually boost the performance of VDI and XenApp environments to an extent that they're better than any physical application or system, laptop or PC, and that allows the project to succeed from a user experience standpoint. Users gravitate to the virtual form factor more than the physical form factor, and that boost in performance is really what drives that for end users, and we create that. We're a software company. Our product is called ILIO. It stands for Inline I/O Optimization, and it's a 100% software solution. What's great about the solution is it's actually completely agnostic to the server and the storage, and that means it works with any server, any hypervisor, and it works with any storage system, whether that's a SAN or an NAS or even local storage, flash SSD. It also complements VMware and Citrix Zen Desktop. So if you're doing VDI, you can choose either platforms. From a XenApp perspective, of course, it's more about Citrix Zen Desktop and Microsoft RDS Terminal Services. One thing that I'm very proud about is that we won the Best of VMworld in the US and in Europe in 2012. And followed up by winning the Best of Show at Citrix Synergy in Europe as well, in Barcelona. And that is for this Atlantis ILIO product. So we're one of the, I guess, the only company today that's actually won a Best of Show for this XenApp technology that I'm talking about. the same year across all 3 major virtualization software. So we're very, very proud and excited about that. And we have a strategic set of partnerships with all leading server and storage vendors. So, we work very closely with Citrix, VMware, IBM, Cisco, and Dell. We've had an enormous amount of customer success. VDI and XenApp virtualization has tended to be extremely risk and error prone for a lot of customers. And a lot of VDI projects, XenApp projects have stalled. But some of the largest, most successful deployments globally today are powered by Atlantis ILIO. JP Morgan Chase has deployed us in 15 data centers today for tens of thousands of virtual machines, very, very successfully. Colt Telecom, one of the largest service providers in Europe, is a very large customer of ours and provides desktop and desktop as a service functionality using our technology. The U.S. Navy and the U.S. Army Medical Command have used our technology to virtualize XenApp in several of their hospital installations to provide medical applications to their staff using VDI and XenApp technology. So if you visit our website, there are a list of companies that have successfully virtualized and eliminated and overcome many of the challenges that come from virtualizing XenApp using our technology. If you recall from one of the slides that we looked at earlier that was shown by Rick, 93% of companies, enterprises today, are planning to virtualize XenApp. They're planning to move from a physical to a virtual server. And about 83% are in the process of virtualizing right now. Typically, virtualizing XenApp is a part of a migration project, and migrating involves 3 things. One, it involves moving from a physical to a virtual XenApp. That's an obvious one. But it also probably means that you're changing the underlying storage architecture. You're moving XenApp from being powered by local disk, local storage, to a shared storage using SAN or NAS for housing the virtual XenApp virtual machine. And for some of you, it might also mean that you're moving between different operating system versions. So XenApp, instead of running on 2003 server, will now run on 2008 server R2. So as you can see, there are a few different moving parts over there: the physical to virtual, the change in storage architecture, and the change in the underlying operating system. All of these 3 have very significant implications from a risk standpoint and from a performance standpoint for your project. So obviously, one of the first things that you're doing when you're virtualizing XenApp is that you're moving from a dedicated storage architecture where you have local disk for each of your XenApp servers to a shared storage architecture requiring SAN or NAS. And that SAN or NAS now is going to become a constraining factor. It's going to become a bottleneck in your implementation. That's going to impact the density of how many users, how many XenApp instances you can put on each physical server. Because virtualization introduces its own set of complexities. And there's one particular complexity you need to be cognizant of. It's called the I/O blender effect. When you're virtualizing, you're essentially putting 2 or 3, maybe 4 instances of XenApp servers on a single ESX host. That means that the I/O has to be distributed and scheduled not by each XenApp instance, but by the underlying ESX host. And the ESX host basically schedules all of the I/O from all the different XenApp instances that are being hosted down to storage, and as a result, blends the I/O from each virtual machine, mixing it with the other one. And that has significant implications from a storage performance standpoint. What that ends up doing is randomizing the I/O and also slowing it down to some extent. And as a result, application response latencies creep up, and over time, these can manifest as user experience issues. So it's a big challenge. You've got to be very cognizant of this fact as you virtualize it. Also, there are many kinds of new performance issues. You've had performance issues in physical environments, boot times, login times. We're familiar with those. But there are some new ones that get introduced with virtualization. Provisioning becomes a fairly expensive exercise. Boot logon times can actually exacerbate in terms of performance and become even worse in a virtual environment. And the biggest challenge you have is whenever you mix applications that are I/O intensive onto a common XenApp farm, those I/O intensive applications, because they're using shared storage, will tend to affect all the users and all the different kinds of applications that are running in that infrastructure. So significant risks from moving to virtualization, mostly because you're changing the underlying storage model that XenApp utilizes. So just to peel the onion a little more, you might ask yourself, why is this the case? Because fundamentally, virtualization technology was meant to virtualize servers that were non-interactive, databases, web servers, mostly workloads that are very transactional in nature. But XenApp VDI, these are interactive workloads. There are human beings who are sitting in front of the computer, in front of a terminal, accessing and running applications, and then they're fairly random in their behavior. From a computer standpoint, very erratic and random. And this interactiveness changes the I/O behavior from a virtualization context. It changes the I/O behavior from being very read-intensive in the case of databases, in the case of web servers, to actually being more write-intensive and a lot more random I/O being sent to the storage system. And storage systems don't do very well when you do random I/O. That's a big challenge that storage systems have, because most storage systems have underlying spinning disks, and every time you do random I/O, the disk head has to reseek to a new position before it can actually service the I/O request. And this causes a lot of the congestion and the latency related problems that creep up in user experience. Also, what most people are not aware of is that as you move from Windows Server 2003 to Server 2008 R2, just the operating system doubles the amount of I/O that is generated in the environment. Just to switch from one operating system to another doubles the actual amount of I/O that is required to be presented to the application. So let's talk a little bit about specific nuances of deploying XenApp. XenApp can be deployed in two different ways when it's virtualized. One way is to simply, treat it like it's a physical machine and provision the whole thing with an operating system, with the applications all installed into the virtual hard drive. The other way, the more elegant or the more operationally flexible way, is to use the technology like PVS to deploy. And that brings up a question as to what do you do with the write cache that PVS needs. So most people, when they're deploying PVS in a XenApp in a virtual form factor, use shared SAN or NAS storage for the write cache. They also try and use local disk, but local disk is very limited IOPS. So putting the write cache on local disk typically tends to lead to a lot of performance bottlenecking. SSDs have been seen as one solution, but SSDs have a problem. Most SSDs don't really perform very, very well with write-heavy workloads. As soon as the variable congestion algorithms get engaged, SSD performance can drop off a cliff, and you end up with the same set of problems that you have with spinning disks. So PVS servers, have their own set of complications when deployed in a virtualization environment, and the choice of storage is very, very critical. So the other aspect of PVS that you need to be cognizant about is that with PVS, the image, the operating system, the applications are actually serviced from the PVS server itself. And so the pipe that connects your PVS server to your virtual infrastructure also needs to be fairly big and fast. Otherwise, you can choke the reads, and that can also, essentially impact your application performance. One solution to get around these issues is to use RAM. What if you place the write cache on RAM? And that's a supported feature. And for a very few set of users or customers, that works very well. You see, the PVS write cache is fairly large in size. It can be between 12 to 16 gigabytes in size. And so if you're putting each of these write caches in memory, your RAM will typically become the constraining factor when you're putting a PVS on RAM. So this is how you can essentially hurt yourself when you're virtualizing XenApp. You can undersize the PVS write cache, or you can use SAN or NAS in some non-optimal ways and introduce a tremendous amount of storage and networking risk as a result of that. And the impact really is three things. Number one, you're going to have to go back to your finance people and ask for more infrastructure. The cost overruns on your virtualizing can be pretty significant. Obviously, most of these challenges you will discover late in the cycle, and so there will be delays in your project while your infrastructure is resized. But most importantly, the critical stakeholders, the guys who sign the checks, they're not going to be very happy, as well as the users, and that can be a massive problem. And this typically is what leads to a lot of risk aversion and people being very, very cautious when they approach XenApp virtualization projects. So this is where our solution really comes in and does three things to eliminate the challenges that I just described. Number one, it eliminates all the performance-related challenges that come from storage. It completely eliminates them. I'm not talking about reducing them. I'm actually talking about eliminating them. And how does it do that? It actually does that by actually eliminating the storage itself. When you're virtualizing XenApp and you're using the Atlantis ILIO technology, you do not use any storage. You do not use local storage. You do not even use shared storage. What you really, and I'll talk about this a little more in detail, what you end up using is the actual RAM off the server as the primary storage. And if any of you have ever tried this as an experiment, maybe where you use the RAM disk and you put some data on it and you try to access that, you know how fast RAM can be. RAM has nanosecond latencies, it's extremely fast. Well, that's what our technology really leverages ultimately. It uses RAM as storage, and as a result, eliminates physical storage of all types completely from the solution. And the third thing it does is it eliminates all those risks that I just talked about, from the where you place the PVS write cache, how big the write cache needs to be, what kind of storage system is underneath, how big the pipes are connecting the application to the PVS or the storage. And all those risks are completely eliminated, as well as the risks that come from migrating from one version of operating system to another. So when you move from 2003 to 2008, the doubling of IOPS has no impact on you. Plus, it supports all models of XenApp deployment, RDS deployment, whether you're using PVS or you're just building full images with clones, with the application's operating system all fully provisioned within them. So let's dive in a little more technically into what our technology is. Our technology, our software, is essentially nothing more than a virtual machine. It's actually a virtual machine, and it gets deployed on the same host as where your XenApp server instances will be running. So in this graphic, what you're seeing is 4 XenApp virtual machines running inside Windows Server 2008 R2 right on top. These little icons illustrate the different applications that are running within that XenApp instance. And the XenApp instance is sharing the host along with an Atlantis ILIO virtual machine. There's one key difference, though. The storage for the XenApp virtual machine is provided by the Atlantis virtual machine. And that it does by providing a NFS data store to the hypervisor. So what the Atlantis virtual machine does is it takes a little bit of memory, puts their software in front of that memory, carves out a RAM storage, a RAM primary storage unit out of that, and presents that as NFS to the hypervisor. Your Windows Server instances, your XenApp instances, their VMDKs, their VHDs, are stored on that NFS data store directly on the RAM via the Atlantis virtual machine appliance. And the Atlantis virtual machine appliance is doing some very, very clever things while it's sitting in line, taking that RAM and presenting that storage. So I'll quickly talk about the internal technology just to give you an idea, how it's doing this. It's doing 5 very important things. Number one, it does something we call application analysis and I/O processing. Our software creates storage that is content and context aware. Our software understands what Windows and what XenApp is doing. Most storage systems have no idea what the application, I would say almost all storage systems have no idea what the application or the virtual machines that they're servicing are doing, because all they see are a bunch of read and write requests. Our software, on the other hand, is able to fingerprint every I/O request from every one of those XenApp instances and understand what that I/O request is, which application, which user generated it, and use that to make some very important real-time decisions, for example, on how to prioritize the I/O transaction. Is this request coming from a user, or is this request coming from an application or a Windows operating subsystem? And how should I optimize the service request? Once it's done with the analysis and the I/O processing, it performs a form of inline I/O deduplication. Deduplication means a lot of things to a lot of people, but in our context, what it means is being able to eliminate every redundant I/O and data block that is generated by these XenApp instances. And that means that we can compact and reduce the physical amount of storage each of these virtual machines requires. Once the I/O has been deduplicated and the blocks that have been generated by the I/O have been compacted, we further perform a type of inline real-time compression. The combination of deduplication and compression is very, very impactful. I'll give you a quick example. If you have a 50 or a 60 gigabyte XenApp Windows 2008 virtual machine. The VMDK or the VHD is 60 to 80 gigabytes. The combination of deduplication and compression reduces it to under 2 gigabytes of physical memory utilization. It actually shrinks it down to just 2 gigabytes. So and that's what allows us now to take RAM and use that as the primary storage itself. There's one additional feature that we provide that we call fast clone. This capability essentially allows us to manufacture at a very high speed and provision XenApp instances for you. So this is an alternative to using PVS in some ways. But what it lets you do is build a XenApp instance in about 5 seconds on demand. And it's sort of an advanced capability that can really help you when you're provisioning very large-scale XenApp farms or you're virtualizing very large-scale XenApp farms. So let's talk a little bit about what the storage requirements actually end up being when you're using PVS for deployment in a virtualization environment and what the impact of using our Atlantis ILIO software with that could be. So when you're deploying with PVS, you're typically sizing for about 8 IOPS per user. And I would suggest this is a safe number because, if you size for the average user, you're usually going to be under during the peak activity periods that are generated in your XenApp environment. You're also going to be sizing, depending on the amount of RAM and the CPU that you have on your host, for between 4 to 12 XenApp instances on each of your hosts. And each of those XenApp instances is going to require between 16 to 20 gigabytes of storage space for the write cache. Yeah. Now, if you make a mistake on sizing the PVS write cache, even by a very small percentage, you're going to have a huge cost impact in terms of having to buy a lot more storage disks to accommodate the size or the IOPS. So if you undersize from 8 down to 5 IOPS because that's what your storage system can support, or you undersize the write cache by a few gigabytes here and there, you're going to have to pay the piper at some point, and that means buying more storage infrastructure. It's a big problem. So you have to ask yourself before attempting virtualization of XenApp, what will the impact of the project be if you get your sizing wrong? That's a very, very important question to ask yourself. So here's a very quick example of a typical XenApp deployment with the Atlantis ILIO technology underpinning it. We've used the industry standard login VSI, benchmarking tool to do this analysis. First, we make it possible to run the XenApp servers completely from memory. It's running from RAM by performing all those storage optimizations that I just described on the PVS write cache. So what we're doing is we're taking the PVS write cache, which is between 16 and 20 gigabytes, and cutting that down by almost 92% and storing it in memory and servicing it from memory. And this means that you can actually, at a very low cost, deploy XenApp with no storage, or if you choose, local disk storage for the PVS write cache. Now, RAM is absolutely the fastest possible data store technology there is. It's faster than flash. It's faster than the fastest arrays. And so the performance of critical activities like provisioning, boot time, application response time, user experience, all of these improve dramatically because of the using of RAM and our software on top of that. The user experience is astounding. So when customers are deployed with shared storage and become I/O constrained, it reduces the density because you really can't put as many users on the same storage system. But by switching that very same system to using Atlantis ILIO with the in-memory storage, this I/O constraint is completely eliminated, and you get an increase in density. And that actually means you can put more users on fewer servers. I'll quickly talk to the cost impact for 1,000 users XenApp deployment. With shared storage, your IOPS are going to be limited by the number of disks you have. So that's the number of physical, SAS or SATA drives that you have in your storage array. And if there's a performance bottleneck, all users will experience a slower response time. So we've used 8 IOPS to show this calculation. So on the left, as you can see, it's 8 IOPS with a NAS or a SAN. But the ILIO software is using RAM, which essentially means it has unlimited, infinite numbers of IOPS. Also, there's no storage there's no storage capex or opex. You're going to save over 80% of the storage cost and the infrastructure cost per user. And this decreases by over 70% to just about $112 per user. So here's the breakdown of cost of server storage in Atlantis ILIO for each scenario. As you can see, the storage cost, the blue part of the graph is completely eliminated, and you bring that down to a very, very low level. I want to talk about one other piece which is very, very important from a XenApp virtualization standpoint. If you don't have a tool that can automatically size, tune, and configure, you're going to have to do all of this manually. And that introduces a tremendous amount of project risk. The Atlantis ILIO software also comes with a completed automated deployment utility and a set of technologies for that. What this does is it auto-tunes, auto-configures, and automatically deploys the Atlantis software along with the XenApp image for you to provision rapidly in real time. And this is a four-step process. You run the utility, it automatically probes the virtual center, the virtualization infrastructure, figures out what resources are available, what the types of hosts are, and using that, it automatically calculates and sizes and configures itself. Once it's done that, it creates these NFS data stores that present themselves as storage. And finally, the next step, you can either provision XenApp with Citrix PBS or do full clones using the Atlantis ILIO fast clone technology. So, as you can see, we've been talking for the last 10, 15 minutes around what the Atlantis ILIO technology can do. We're focused on doing two very specific things. One, eliminate the storage performance I/O bottleneck. How? By using software, compute, and the RAM on your server to become virtual storage. Don't use physical storage. Use virtual storage created by the Atlantis ILIO on top of the RAM that's on your server. Two, eliminate the storage network bottleneck completely by actually servicing all I/O requests that the VMs are generating from within the same host. So what does this mean for you? It means a couple of things, very important. Number one, you don't need any storage anymore. You don't need to buy additional SAN NAS. You don't even need local disk, and you certainly don't need flash storage to grow or to build and grow your XenApp virtual form. You don't need to invest in expensive storage network traffic or fiber channel. This is a big deal because that's additional cost and complexity. And if you've been doing XenApp for a while, these are things that you really didn't need when you were doing XenApp, but virtualization is sort of imposing these new taxes on you. You're going to get a tremendous user experience because RAM is the storage. It's no longer a physical spinning disk. We've eliminated the risk of deployment by using full automation. So you simply use tools instead of human beings and calculations to size, build, and make the deployment. Ultimately, it's all about just using software, server, and memory as storage to get to that success factor. So with that, I want to hand it back to Rick. Thank you very much.
Chetan, thanks so much. That was a great presentation. So we're about at the hour now. We're just going to take a few more minutes. We want to kind of tie this together real quick. There's a lot of questions. There's no way we'll get a chance to do them all here. We'll take a few questions, a couple of repeaters. So we'll ask those of the experts, and then we'll let you guys go, and we'll answer the questions. We'll all follow up very quickly via email. So, hopefully today's presentations resonated well and showed how these two great products address the two biggest inhibitors of a successful virtualized environment: quick identification of root cause performance issues and cost overruns due to the implied need for high disk I/O capability through an expensive SAN infrastructure. I think Chetan dispelled that. I also want to point out quickly, and Chetan mentioned it a few times, today's topic was about virtual Citrix, but a lot of the questions we're asking about other applications. Anything that gets virtualized, including, and very much so, VDI, all of these principles apply there as well. You would never want to go into a VDI project, a large-scale project, without great visibility and without taking consideration the cost of the SAN that you might otherwise have done. So this is not limited to virtual Citrix at all. This is really anything that's virtualized, any kind of application. Finally, let's go to the last one. Try to move a little quick here before we lose everybody. So we're often asked, and it's actually a couple of questions were on this also, so the slide was timely. When should these products be introduced? The general guideline is as early as possible, as cost and problem avoidance can be achieved when these technologies are built in early. There's a lot of the major VARs around the United States, around the world, that are building both of these products into their reference architecture for virtualized Citrix and for VDI because they want to be as cost conscious as possible, and they want great visibility as these things scale. But one thing we've learned is there's no static environments, and as soon as you have some success with virtualizing, it will proliferate at a very fast rate. So even if your early deployments, had no performance issues and you're okay in terms of cost, you should still be taking a very serious look at this. As you grow and scale and these things do proliferate, the inevitable bottlenecks will occur. You're going to have the choice of either trying to spread things out without great visibility or spending a lot of money on hardware to remediate, and that's not the right approach. So it's never too early or too late to architect a solution properly. So with that, I just want to ask a couple of questions of the panelists, Chetan and Bala, and then we'll let everybody head out. So Bala, there's a couple of questions that looked like this. So can EG trace back from the user experience issues all the way back to the root cause, no matter where it is in the environment?
Good question. The simple answer is yes. From an end-to-end standpoint, as I talked about earlier, we look at the user experience issues, how user is using the services, and from the services and applications used, we can trace it back into the infrastructure pieces. Since we are looking at all these infrastructure pieces and applications end-to-end as a single cohesive unit, for us, we are able to see the direct correlation between the user experience impact and a potential infrastructure issue or an application issue that could have caused the user experience impact. And this could be in a combination of different types of environments, physical Xen infrastructures, or Xen server virtualized with XenApp, or ESX virtualized with XenApp. In any of those different combinations, we would be able to track user experience issues back all the way down to whether it's an application specific problem or an infrastructure-related issue.
Great, thanks, Bala. Hey, Chetan, question was, does Atlantis ILIO work with full clones if you don't use PVS?
Thanks, Rick. Yeah, absolutely. The Atlantis technology provides storage that supports both full clones that have the operating system as well as the XenApp installed in them, or you can use PVS alongside the Atlantis ILIO technology by putting the right cache on the Atlantis ILIO data store and using PVS to serve up the image. So both models are supported.
Okay.
Now, we have a feature that we call fast clone that actually allows you to rapidly provision full clones. Typically, when you're creating a full clone, you have to clone an image, which, depending on the size and the type of storage, can take 20 minutes to an hour, various factors included. What our fast clone technology does is, at the ILIO RAM store level, it's able to rapidly manufacture that XenApp instance for you. In 5 to 10 seconds, it can give you a full clone, as against to trying to do that using the conventional tools that can take up to an hour. So provisioning times can be cut down by almost 92 to 95% using the fast clone technology.
Great. Thank you. Hey, Bala, a couple people wanted to know, does the EG suite rely on other monitoring tools to collect the performance data?
No. Essentially, we can collect all our performance data that we use for our performance analysis. So we have what we call as data collectors. They can either run on your system or run remotely in the environment, so they could be called as agent or agentless. So we collect all this information ourselves from all these different infrastructure and application pieces that we talked about, and have the ability to automatically correlate it. However, we can also support collecting information from other existing tools that you might have in your environment, and use it as part of our root cause analysis.
Great. All right, I'll just ask Chetan one more, because there are a lot of questions, and people still on. We're getting a lot of questions about getting the presentation and getting the link. So everyone who attended today, we have your email. In a couple of days, you're going to get an email with a link, and it's going to go to this recorded presentation, as well as a link to pick up the slides. So don't worry, you'll have everything in your hands in a couple of days. So last question for Chetan. Can you use Atlantis ILIO without Citrix XenApp on RDS deployments?
Today, ILIO is only supported on virtual environments. So if you're virtualizing Citrix XenApp or you're virtualizing RDS, this technology will help you. It's not meant for physical deployments and is not supported in a physical environment.
Okay, great. All right, I think we're going to wrap up, because it looks like people are logging off, but about 90% of the attendees are still on now, which is great. So, I want to thank Chetan and Bala for the great presentation, great information. As you can hear, we were talking fast. We try to put a lot of information into an hour time frame. By all means, you see the slide here of contact information. Either call us or email us. And if you need more detail other than just the presentation, want to speak to an engineer from either company, just contact us and we'll get back to you right away. Again, before you log off, you're going to see some questions. Please take the survey real quick. And again, we appreciate everybody taking the time to attend today. Thanks, everyone. Bye-bye.